All right.
So hello recording. The context of this is a code review of the blockchain reorg, which I've been conducting over the last couple of days and coordinating with Anka to figure out what will be the best way to approach this. So for me, reviewing the reorg was quite challenging. It was really hard for a couple of reasons. One, it's like a lot of code. I think it's like 5,000 lines or something like that, which is probably about a normal program. Two, it's like the domain is quite complex of what it's doing. It's like a bunch of state machines that are sending and receiving messages, all wrapped up in a bunch of peer-to-peer coordination concerns. So that's really hard. And then the last part that made it hard, which is potentially an opportunity, is that we, in the current iteration, we've kind of divided the state transitions into three mechanisms that are pretty wrapped up together. So they're kind of really one thing. So those are, I would guess, the reactor, the FSM, or the reactor underscore FSM, and then the pool. And then I would include like a peer object as part of that pool component. So does everyone know is everyone following so far? If I talk about those three things, are we all on the same page? Yes? Okay. So there's really a bunch of message passing, but there is one FSM, which is wrapped, which is the Reactor FSM. But then there's state in the other things. So one of the things that me and Anka talked about yesterday is that if they are different, if they all manage different state, right? Why not just make them completely independent state machines? And that would be somewhat of a change, right, to the current implementation, insofar as instead of like random the peer having or the pool having access to the reactor to send a message when it receives a certain thing, that if there's a pool FSM, then it takes in messages in state and outputs messages and events or something like that. And then those events can or cannot result in dispatching of messages to peers or whatever. So really, what we're looking at is splitting up like that one big chunk of state transformation probably into three, which would allow each one of them to be tested independently, and they would be threaded together in a single place, which would be the reactor. So the reactor's job would be coordinating message dispatch to different state machines. And then what the reactor test would be is effectively an integration test between state machines. So this approach was taken or was suggested because I think it's easier to understand the working of each one of those parts individually. Is probably easier to implement and test them individually and get it reviewed. Like, I think it's very hard to review the 5,000 line of code change that we have now. So this would allow us to split that up into separate parts, get feedback, and then integrate that into the greater scope piece by piece, which would give us like a nice trajectory for development that would have more continual feedback instead of like these huge, like multi-day deep dives. And hopefully, I think there's been a couple great reviews from Zarko. I know Anton looked at it, and I spent some time with it, but it could probably use more. So it would be about, taking a direction which would integrate more people with less effort to get more feedback. Does that capture our conversation, Anka?
Yeah.
So Sean, can you, maybe I missed a sentence or two at the beginning. So what would be really the high-level roles of these three state machines? Can you explain this?
Sure.
In just a few sentences.
So I guess the block of what's Reactor underscore FSM is kind of like the real blockchain FSM that does states like waiting for block, right? So I get a message, say, do I want block parts or whatever, and those come in. The pool is effectively an aggregate over peer state. So if I receive a message from a peer that I have this height, and then I receive another message from a different peer that has a different height, I need to know what is the greatest height that I've seen.
Okay.
For instance. And then the peer object is also somehow an FSM, as in messages I receive from a peer are essentially giving me a time that I've heard from that peer and maybe bandwidth that I'm receiving from that peer block comes in. And that would be where we would try and capture the timeout logic. So just continuing on from one thing that made this quite complex, and actually Zarko, it was your comment that really inspired me to dig in here, is that timeouts, the individual peers in the current implementation have like a ticker or like a timer or whatever, and then they emit timeouts every once in a while. And there's a couple conceptions of time, right, which require kind of deep connection between the pool and the reactor, or the peer and the reactor, or the FSM and the reactor. So another idea that me and Anka came up with is, what if the reactor had like a wall clock-like ticker, and it sent like a check time event down through the FSMs. And then each individual FSM, like say I'm a peer, and I receive a real message that's pertaining to me, and then I report in my internal state, I was seeing at this time. This is my last time. The reactor that is then responsible for sending a check time event, right, which is just time.now, right? And then as a peer, I'm going to compare the wall clock from the check time event, right, to the last time that I've processed event in my internal state. And if that exceeds some threshold, right, I'm going to emit a peer timeout event, right? And that's going to go back into the chain where other people could say, like the block FSM, for instance, can say, hey, this peer has timed out. I should probably find a new peer. Or sorry, that's probably the pool that would do that, or something like this. Another component would take that peer timeout event and decide what it means to it. So effectively, there would be no linking between the peer state and each FSM. It would exclusively communicate with events.
You're basically saying remove the ticker from the individual peers and put the burden on the reactor to submit this kind of message to everyone.
Yeah, and then no cleanup, no, like just reduce the amount of state that we would be carrying around in individual objects.
Just a question, I have not seen that part of the code, but do we have any kind of like monotonic weld time? I mean, I have seen like in other cases where, I don't know, somehow like NTP updates your clock and then your weld time is incorrect. And so you need to be sure that it's always monotonic, it's always increasing.
I also had that concern about time, and especially since time can be used to manipulate behavior. Like if I could tell a process, this is your new time, this is your new time, then it seems to me like that would open up a lot of attack vectors. Like what time library are we using, and what properties do we need from it? I actually don't know.
So we use Go's, and as far as we know, Go's time is, I mean, they had bugs in the past, but they seem to have fixed them all. They were kind of catastrophic, but the time is monotonic.
Okay.
You know, Google uses it across its infrastructure, so you know, I would hope that's good enough.
Yeah, but if suddenly you get like an NTP update in your host, the weld time, it will kind of go back. So you need to be sure that if you use that as a timestamp, you need to be sure that you're not just adding and subtracting timestamps, right?
Yeah.
It's just like I don't know, I have that bad situation in the past, so I thought it was a good thing to tell about that.
Yeah, it's because if it were not monotonic, then we could take a timestamp at one time, of which, like in real time, the subsequent timestamp might actually should be after, but would be before.
Yeah,
as it was adjusted. That's the case that we're worried about. Yeah,
correct. And you can have like a bandwidth issues because you are like calculating back the delta, and I mean it can like result in a lot of stuff.
My understanding is that within a Go process, the Go standard time.now is strictly monotonic.
Okay.
Yeah. We can double check all that, but I believe that's the case.
Yeah, it's a minor detail, but good to take it.
So one of the reasons I like in principle Sean's proposal is the biggest pain was testing things without timers running, right? and not waiting for timers to trigger. Maybe, Sean, you can explain a bit how we would do that with.
Yeah.
So it just turns it into messages, right?
Exactly. So we would set a message with a, we would say we could just send one event with time t, and then we could hard code t plus delta or whatever, and then we could control. We could make sure that delta is bigger than the timeout threshold. We could hard code it. So it essentially would make all our tests atemporal and deterministic.
So then, because that's a part I didn't completely understand after discussion I was thinking we discussed yesterday.
I guess, yeah.
You mentioned, for example, you send the periodically from the reactor in a normal operation, we would send like a time event to the different components. And then after, let's say, 20 milliseconds, we send another one and another one. And then it's the component who compares its time with the current time to make sure, say, 15 seconds expired.
So say a peer would have a last touch timestamp internally.
So then when we test, we're going to fake the wall clock and we'll say, what? I mean,
the event is, so the event would have a timestamp associated with it, which would be part of the test script. So in the test would probably look like a list of events that are provided in sequence, right? That are being passed to a single method. And then the expectation on the other side is the event that we would get out. So we would say, I'm going to pass you to one event, like this is your last block that you received or something like that. And then another one's going to be a time check, which is explicitly going to be with a time with some timestamp that would trigger a timeout. Yeah. And then the expectation of the test would be, did you give me a pure timeout event? Sorry, there's a fight going on.
Yes. I think it's fine. I had a small concern that we're doing this just because we cannot test otherwise, right? It's not because it's a natural thing to do. A natural thing to do is, for whoever needs a timer to start a timer, and when it fires to run the timer.
Yeah, I think that's definitely one way to do it. I think that the trouble with that is all the cleanup code around like timers and stuff like that. So if you start it, you have to stop it. Otherwise, there's this lingering thing, and you have to remember, oh yeah, I need to.
Yeah. I mean, of course, you have to do it.
Yeah. So there's that, and we could kind of the thing I like about this approach is we could really isolate the test specific to a domain object, right? So like, as a reviewer or whatever, I could form some set of expectations of like, if I get this event, I expect that part out. And that's like literally what I'm reading line per line. And if something is wrong, I could look at, the latest gossip paper or other material and say, hey, that doesn't line up with my expectations. The current test aperture, like the infrastructure that we need to test the reactors in asynchronous code right now, it's very hard to see the domain in that code. Actually, there's just a lot of things about cleanup, about injecting specific state into specific objects at specific times to produce something that tells me that I'm right. As a domain expert, it's that stuff was really hard for me to understand. It was worthwhile. I'm glad I got it in the end. We were able to get here. But the idea is really just to make this code very, very easy to review by people like Zarko and his team.
Okay, and the other small concern I had yesterday, and I just wanted to say now is that I'm okay with the FSM, the main FSM, the pool FSM. I mean, it's a subtle distinction there, and it took me a while to understand it. It's the fact that for me, the pool and the peers are just, it's not really, I mean.
Could be.
It's a state. I mean, we have to define state. I mean, every submodule owns some data, right? The pool has a list of peers. If we consider that a state versus just data, then yes, we can think differently, you know.
I guess I'm also not sure what the right split is, being perfectly honest. But the way that I would frame the discussion on determining the right number of FSMs to have is like, how many distinct things do we want to test? If we were having a conversation about this behavior, how well scoped can we make that conversation?
So it's back to my point that we're doing this design, and I'm not against it. I actually start to like it more and more. It's just that we're doing it such that we test easier.
Yeah, in review. Yeah.
In review.
Yeah.
So, but you know, I do like it. I'm not saying I'm not like it.
Sure, and I think we all need to come up with
because we're trying to test different.
Yeah, in my perspective, that's usually I rank that very, very highly. Like how easy a test is to code, and how good it is to have a conversation about a domain around the artifact. I rank that very highly. There are probably also like performance considerations that we should be mindful of. I'm sure, you know, I'm very, very open to having that conversation. I'm just, yeah. My preferences, and I'm interested to hear other people's preferences, is like the design should be one that makes testing a specific domain object and having a reasonable conversation about the domain easier. And that's the kind of angle I took with my recommendation. If there's other criteria, we should for sure integrate them and make sure we don't, you know, back ourselves into a whole of a performance nightmare scenario. Or what would you say were the other dimensions?
Yeah, so we do have definitely understanding or simplicity is at this point the major, I think, requirement, because if kind of we fail there, we'll just introducing the bugs, and then, you know, like performance with the buggy code seems like a wrong requirements to target. And so I kind of was having the same feeling. So I was super happy to see that you guys are proposing also to split this thing, because the blockchain reactor itself is even not so complex compared to the other part of the code. Like state machine itself compared to the consensus can be seen as a simple one. And so if you don't figure out a way there on a blockchain reactor to be able to address this, then with the more complex stuff, we'll suffer even more. And so I was having exactly the same feeling. And recently with the Gossip Reactor and the work we are doing with Danielle, the same thing hits to me. So I was looking at this code a lot last year, and I have a feeling that I understand it pretty well. And then when you read the spec, it's so many cases, you know, what happens when I get this message? What happens when this timeout trigger? And so like you right now with the current architecture and the code, it feels like you need to understand everything. Otherwise you're not able to say whether it's correct or not. So in order to review the stuff, you need to sit, you need to devote a few days, and then you can maybe do something in a good way. So we definitely need to figure out a way to split this into modules, come up with more meaningful abstractions, which you can look at it in isolation. So so in that sense, I think if we can really split this state machine into the parts, which apparently you have a pretty good idea as they are not sort of interfering with each other. And ideally also we would have a good name or like intuition what this thing is about. I think this would make review much easier, you know. And in terms of performance, there shouldn't be hopefully there shouldn't be a big penalty, because the protocol logic is normally not the bottleneck. So bottlenecks we're having at other parts. So
Zane, you want to chime in?
Yeah, and timeout stuff. I'm not sure that I fully understand the proposal, because I was having they called me from the kids' school, so I needed to take a call. So I, again, maybe missed a key sentence, but it seems that the proposal is more or less to extract the timer trigger from the module itself and do it from a sort of central place, so it can be tested. Yeah. Yeah.
Yeah, and timeout should be events that could be consumed by multiple different FSMs.
Yeah.
Someone has ownership over determining whether the timeout has happened or not. That should probably be some like peer state FSM or pool, whatever we call it.
Yeah.
But then there could be different domain-specific interpretations of a peer timeout.
So this thing is essentially triggering the timeout events when they are triggered, but the alarm, like setting the alarm or whatever we want to call it, like this can be done by more or less anyone. So you can ask for this guy, can you please notify me after 5 minutes?
That's right. That's right.
Yeah, this seems like a very nice design in my view also.
And this part stems from the conversation we had with XLA at yesterday's like peer-to-peer work group. And the question was like, are timeouts or like right now we have the peer, right? Which has a lot of transport specific concerns, but it also has like individual domain concerns. Like we set state on it and we do lots of crazy stuff. And I guess what we asked if like, could we split the peer into like a domain object and then like a transport management thing? So you could have one without the other. So I could have a peer, but there's no physical connection underneath it. It's like an abstract thing. And then it has some send interface, which can be write to a map or write to a carrier pigeon or write to, whatever it needs to be, we could take care of that separately. Okay, so now that makes sense. But then let's look at stock, what the things we have attached with a peer now, and then put them in the buckets. And sometimes it's obvious, right? And sometimes it's not obvious. And a timeout is one of those things that's not exactly obvious over whether it's a transport, it should be in the transport domain or in the business domain. So in this case, as like a short-term solution, I'm putting it in the Reactor domain, or like let the Reactor decide, because it's like, it seems like a protocol level concern for the blockchain Reactor, as in like, when I lose my peer or whatever, I need to find a new one. So I could take ownership of that for now. But open to discussion. I have some notes that from the work group in Notion that I guess we'll go over at some point. Yeah.
But I think it's super valuable to look into separating things. I mean, this also applies to the light client Rust implementation. Being able to clearly separate and differentiate what our sort of business domain is and what the sort of transport layer and the more technical concerns are. And I'm definitely a fan of readability over performance at first, and then optimizing once you've got it working.
Cool. So it sounds like we're close to agreement or at agreement. Where are we at? We like this idea?
I think so. I mean, especially for this has been first of all, there has been rampant mismanagement of timers throughout this code base for years. So they've been a source of leaked memory, race conditions, non-deterministic behavior in production, and then in testing, same thing, right? So being able to remove them or control them better, in a well-defined, clear way, and be able to test without relying on sleeps is just a huge, huge win. And so kind of, again, going back to Jarko's point about like using the blockchain Reactor as like, the example to start to test all these ideas about how to improve the architecture. And if we can't do it there, we can't do it anywhere, because it's kind of the simplest one in some sense. Probably. So I think it makes a lot of sense to try to lift the timing out as much as possible from the interior systems and bring the concern up so that it's kind of injected, so that the tests of the interior stuff don't require tickers. It'll beg the question of, well, then how do we test the Reactor? How do we test the kind of, integrated whole? Do we still need something time dependent in the test there?
So I love that question, because I'm really looking forward to tackling that part with Anka probably on Monday when we're all in Berlin. But yeah, in the ideal, like everything is wrapped in the receive method right now in Reactor. So that would be like the main point of entry. So it'd be nice to create like something out of that. So we have like time concerns and like network connection concerns or whatever that are wrapped in that receive method. So the integration test between FSMs, it'd be nice if they didn't have any of those. If it was like some method that only did once I have a message, right? How do I thread that through the different FSMs? And then I output to something. I'm going to produce some. It's a composition of FSMs. There should be a method within the Reactor that's a composition of FSMs, still independent of network and time concerns, right? And then the actual on receive, maybe we do like a full integration test, which includes network and wall time, right? But that could be completely separate from the test that test the composition of the FSMs.
Yeah.
Oh yeah. So TBD, I'll probably tackle that on Monday.
Very cool.
Yeah, one thing which is, it's a bit orthogonal. It's just, I was wondering if we can get rid of some of those timeouts, although this is more like, it's a bit orthogonal question, but it feels for me that at least some of those logic could be removed by purely message handling. So like instead of periodically sending event to a state machine, so it does something, that you can be more message driven. So when message comes, then you do something. This is something which is more, it's a bit orthogonal to this work, and probably shouldn't be done the same way, but we can maybe get rid of some of those timeouts by being more purely message driven.
In the blockchain reactor?
Yeah.
Are you talking about the there's a bunch of time channels, there's a bunch of tickers at the top of the on receive or the pool receive loop. Are you talking about those ones? Like they say like, oh, you should check for if the block is complete in 10 minutes or
Exactly. Yeah. So all those stuff like I think that partially is there because then it's how it feels more secure, like that you will not end up with some sort of deadlock. Because you will at least, no matter what stupid thing you do, you will have a chance 10 milliseconds after or something like this. But it adds some complexity, and we are losing a bit reactivity there because sometimes we wait some time, although we can maybe do immediately some things. Now, what is not clear to me in terms of understandability of the code, whether removing those timeouts would help or not. And so this is something which kind of would be interesting to see. But I think that at least for some of them, probably they can be removed.
Yeah, I'm just hoping that the test is, because right now, if you look at the Reactor FSM test, right, there's probably about 300, 400 lines of boilerplate, of just getting things into shape that they could be tested. So I think that will mostly go away. Or in the ideal, and it'll take some time, and it's not going to be a big bang sort of thing, but it's mostly just going to be message in, message out assertions, like different scripts, different scenarios, and very, very little. The Reactor FSM test.
Which one? The test itself? Preparation.
I was just looking at the.
Because I didn't think this would change dramatically. I mean, the format will change, but we still need to test the FSM, how FSM behaves upon a sequence of events.
Exactly. So that would be mostly script. So all the, make block responsive. Actually, that would probably be the same. Okay, I see your point now. Actually, most of the infrastructure is about.
In a way, this is the part that will change less because
that part will. Yeah.
Here, for example, we don't run any timers. It's all event driven. Absolutely everything.
Yeah, you're right.
Yeah, maybe we're going to remove some of the, because this one we have a bit of some logic looking at the pool because I thought it's important. It's, as you pointed out when we discussed, it's not only testing the FSM, but also a bit of integration with the pool. It's not much, but it's something there that I thought it's important. We can remove that and make it purely an FSM. But other than that, I think what will change dramatically is the peer testing. So the peer test will not have sleeps, ideally, and yeah. So to Zarko's point, I think the code, the functional part of the code, maybe it's not going to change that much. It's the interactions between the module that's going to change.
Yeah, precisely.
So if that is hard to understand now, the functionality, we need to fix that. But I think Sean's and everybody else's point, and I had the same trouble, is the way we communicate between the modules is not nice right now.
Yeah.
Especially around the timers. For me, the timers are the pain here. The rest is easily fixable. I mean, it's basically from the FSM to the pool is just add a peer, add a block, remove a peer, remove a block, or it's very basic functionality, and I don't think it's hard to understand. But the timing is really, the timers are really.
Cool.
So I think, I don't know if we should vote or what do we do next. I am all for start making changes, and maybe we do a checkpoint at some point and see how they look. So everybody gets excited, more excited if they are now.
Well, I'm actually super excited about this because, like as Bucky mentioned, right? This is not, I think this is a huge task for us, like as a team, to learn about evolving a mature code base or maturing a code base that exists, and figuring out like, how do we do this and how do we make major changes and get them accepted by the validators, because it's just going to be part of the game. So if we can get good at it, it'll really bear dividends.
The one thing I would really like to see, and I don't know if it makes sense at this stage or how we want to think about this, but this is it's a huge PR, and it's been outstanding for months, and we're continuing to work on it. I wonder if it might be possible, especially given the direction we're going in, to start merging smaller pieces, or to even merge the whole thing and start working, like put it behind a feature flag and start working on it again. I don't know what people think the right approach would be on that front. But
what's your motivation for integration? Is it because you want a test net running with it sooner, or?
Kind of, yeah. I'd like it to be able to be tested sooner. I think I don't think GitHub pull request commenting scales very well beyond a certain size. So once the pull request accumulates, what is it, 100 comments at this point? It gets harder and harder to work through. So kind of having the review process happen in more manageable chunks is kind of my concern now. So it's really about that, yeah.
Well, actually, Anka, what do you think about putting it behind a feature flag? I think you would.
To do what, sir? I didn't
put it behind a feature flag. I think we talked about this.
Yeah. I mean, I think we should do that. But I'm wondering, because at this point for me, the pain points are the way the FSM communicates with the reactor and the peer timers. So I'm wondering how, and I'm not saying if you would be open to this, but I'm wondering if we could do the change you're proposing in these two regions sooner, and how long it would take, and get rid of the interface between the pool and do a message-based. I think that should be easy. The timer stuff, I think maybe it's a bit more complex, but, and then we can separate the 3 FSMs, make 1 or 3 instead of 1. So do the pool and peer FSMs in a second iteration.
Yeah, so here's the tricky part. I guess there's two different routes of attack. You can go from the inside out or the outside in, right? From Reactor integration tests, fixing the integration between the Reactor and FSM first, and then going down, or going the other way where you start with an FSM you split the FSMs, you make them completely independent, you test them independently, and then you can integrate them piecewise. So although I see that the pain now is definitely at the integration level, and there are some quick wins that we could have there. From a review perspective, I think it'd probably be easier to go the other way and to do it chunk-wise, because then we could integrate people like Zarko and his team really, really early. Very, very soon, because they could read the test and map it onto the spec, and we could do it one at a time. So if we could, I think if we could bite down our mouthpiece a little bit and make a power plan, like go without. If we could prolong integration, then we'll pick up speed by just having more consumable chunks sooner.
So the goal here is to, now we are just talking about like the review process, how we can review this in a most kind of reasonable and secure way.
We're talking about like a plan, like what are we going to do first, such that what we do can be reviewed continuously instead of after a long while.
And so but this necessarily doesn't need to be educational in terms of like community and also like follow-up work, because I'm just wondering, how when we start refactoring the other parts, how frequent we would be in this scenario,
I think we need to avoid being in this scenario again, where and kind of take the approach that Sean has been taking with the peer behavior, where you build functionality and data structures and merge them before integrating them, and that way they can kind of be reviewed in isolation, right? So if we go at this with the consensus reactor, we implement the consensus state machine, just the core thing, don't hook it up to anything else, write a small, simple module, test it, merge that, right? And then we can start to write those pieces and then eventually merge them together. And that way each PR can remain small and focused. And if we find further down the line that integration is going to require changes, that's fine. They happen in an integration PR or something. So
but right now, if we more or less like starting from the code we have right now, if we would follow such approach, would this be too painful or like too much work, so that we also sort of demonstrate this process, so it's a really clear path,
you mean to try to do this now with the blockchain reactor?
Yeah.
No, but the problem right now, Zarko, is that the way to do it is pretty much the way people reviewed it, because of the way the modules are connected. So you do review of the peer and you're happy with that. Then you do the review of the pool, and because pool talks to the peer without any messaging, with any abstraction, because you understood the peer, now you probably should understand the pool. It's not very, very complex, right? And then you start reviewing the FSM, and then you review the reactor. You cannot have one person review the pool, one person the reactor, one person the FSM in isolation, because you kind of, and even the commits, you cannot just commit the FSM, right? It won't compile, it won't work.
Okay.
So I think the idea is to be able to somehow understand them in isolation. Okay, so back to your question, Ethan. Let's say we do this. We take the current refactoring and we put a flag, a feature flag. It's fine, it's there. And then what? The idea would be that we can test. We can have people kind of switch back and forth and do a comparison, or what's the goal?
Can someone I don't understand this feature flag thing. What does it mean that if we just...
it means we have both implementations of the blockchain reactor in the code base, and you can just configure which one you want to run. They're both interoperable. So that way you could run on the Cosmos Hub with the new blockchain reactor and see what it's like with that. So there's basically two streams. One is, my concern is managing the review process in a massive PR, right? Like just opening the tab takes too long. Maybe that's Chrome's fault. It's a separate issue, but that's what I'm talking about, right? So I'm motivated to resolve that. And so I see two ways. One is we just, get the feature flag done so that we can just merge it as is and pick up, start from there, kind of open a new PR to start commenting or whatever. And that would be, you know, that would be an approach driven by kind of the historical state of things, of where they are, and so on. The other approach would be to start breaking up the PR and make new ones, like not merge the current PR, and start making new ones with the components to actually model how we would like to do this, say, the next time. So the first thing we do is bring in the peer, right? And that way it'll be a small PR. It's just the peer and its test. Anyone can review it quickly. It gets merged, and then the peer is merged, and then we can do the pool, and then, you know, the FSM, whatever. I don't know. So we can think about trying to actually break it up and simulate bringing them in one PR at a time. Of course, you wouldn't be able to run the new blockchain reactor until they've all been integrated, but yeah, I'm just worried about continuing to have this.
Is there any rush for the feature flag and do some testing? Because I mean, I think we all agree we want to do the right thing and do the splitting and everything.
Yeah, no, there's no rush. I just don't want to ever open that size pull request.
Yeah. I totally
with that many comments, you know.
But Anka, when we were talking yesterday, it seemed like there were at least a few things missing before it would be sort of feature complete, or like, say, alpha quality.
Well, I mean, yeah, but if, let's say, this would be in a shape we would like, it would be okay to merge even the way it is right now.
Okay, great.
Because there are things we still need to work on, but those things are anyway superior to the current blockchain.
Yeah.
So, I mean, yeah, I'm not sure. The other thing is I did quite a bit of testing with Gaia and Cosmos recently, and things seem to be okay. And in terms of functionality and behavior, I don't think there'll be a whole lot of changes with this new approach we're going to take, right? So I'm not sure if it's worth just doing. Now that we know it's working with the current architecture in terms of the routines and everything, that if it's worth doing the feature flag. But I think the feature flag it's interesting on its own. To add this idea to have multiple versions of reactors working. So from that point of view, I think there's some value.
But like, why we can't do both? Because I don't understand. If you do feature flag and then we don't create these PRs like in a reasonable way, it's hard to imagine how those PR would look like. So I'm wondering, why not just putting this as behind feature flag, and then we then do the proper PRs.
Yeah, I think that
the problem is you commit something that hasn't been properly reviewed.
I mean, even if it's alpha quality, right, and it doesn't pollute any other package or functionality, it's just going to be used in a test net. Yeah. So the question is it contained? If it's behind a feature flag, and the benefit for me, I think what Ethan is getting at is that we can close that enormous PR. You know, like working in that space is probably going to become, or is already, unproductive. I mean, it hides whole files. Like, they're so large that it just hides the whole file. So I didn't realize, anyways. So I think there's a lot of value into closing this chapter of the blockchain reorg odyssey. If we could get that feature flag done.
I think something, and maybe this is something that Ethan can clarify. I mean, when you mean feature flag, is it runtime, or we are talking about conditional compilation? Because it's very different. I mean, what John is saying is very clear. If you have like runtime and you forgot to check for the flag in any of the pieces that have been like merged there, it can be really bad. If we are saying like swapping a module and doing conditional compilation, is a lot safer.
Yeah, I think we're talking about runtime. I think in this case, it's isolated enough that there's only one place where you really have to worry about it. And so you just deal with it in the one place. In other cases, I think you're probably right. If it was something that's a little bit more threaded throughout the code base and used kind of all over the place, we might want, to do something more like conditional compilation. But here, I mean, the blockchain reactor is such an isolated component that no other thing depends on. We never switch back to it. It's not a dependency of any of the other packages. I mean, except for the store, but the store didn't get changed here at all. So I think given the context, it's safe in this case to just do the runtime thing. Yeah. And the default would still be the original, right? So.
Yeah.
But yeah, that's a good point for other refactors to think about. Yeah.
Yeah, that's just not to use the same term for like two of the cases. Yeah.
Yeah. We do that. I mean, we have that for some of the, like for using the C libraries and obviously.
Yeah, exactly. For CGO, we already have that. Yeah.
Yeah.
Cool. So just to, put forth the actual suggestion, what I'm hearing is that we should do the feature flag in the current PR, close that up. We meet on Monday. We figure out what the dividing line is between the FSMs, and then we start attacking that in subsequent PRs.
But they would essentially start from the scratch. Like we will have a third folder.
Yeah.
It will be a folder V2 now, or blockchain reactor temporary, where this new thing would be moved on slowly.
We will end up with 3 blockchain reactors. We'll have a feature flag with
5.
And we do one in Rust also.
No, as long as they're compartmentalized. Actually, like I was talking a lot with Peter about this, and actually when I was working on ADR30, I literally just made an ADR30 consensus package. Great, do it, start over, go piecewise. Anytime, like that's a good sign of our design that we can do that.
Mm-hmm. Cool. Okay.
Is this what we're doing? This is what we're doing.
Yeah. I mean, we may want to nest everything under one blockchain package so that we don't just have like, at the highest level, multiple blockchain packages, because it's going to start to look gross. And I have, I care about that. So maybe we have one blockchain package and we have V0, V1, et cetera, or something like that.
This is nice. Yeah, this is actually, so yeah, they might even, this might even happen sort of by design, that at some point we might have multiple versions.
Yeah.
So it's not just part of development.
Yeah, exactly. Yeah, especially for like the mempool or something like that, right? That's a case where you might really have distinct implementations that have different functionality. So.
Okay.
Cool. So that sounds great.
So, I mean, what should we do together, Anka, and what should we do separately? I mean, we got like one more day, and then everyone's going to get on a plane. So it's not like
you're asking what we should do this one day.
Yeah. What should we do tomorrow?
Take a day off.
What do you mean?
No, I think we should start tackling the feature flag on one side. On the other side, we should maybe write a small APR with maybe for the peer. Start with the peer or high level, explain a bit the new concepts.
Yeah. So I have a bunch of notes that
example for the peer, and then we can start coding the peer and put it up for review. I think it's an easy one. So it's a good place to start.
Yeah, I think that sounds very, very good. A final comment, which came out of the conversation I was having with XLA yesterday morning, was that usually in the ADRs, there's like a trajectory, like a path towards implementation, or at least in ADR 30. And I think this is something that we should put much more emphasis on in the design stage. Because I guess the good thing about an ADR is the person who designs something doesn't have to be the person implementing it, right? But I think we need to be very conscious of like reviewers in this process as well. Of like, we know that this is gonna be a process. What is that process gonna look like? And there should be much more feedback going back and forth, being like, I don't know if we could split this up. If we can't imagine of a way to split it up, it shouldn't get past the design phase. It should keep iterating there. Well, that it's a good sign that we're able to do this now. Very, very happy with that outcome. I think it would have been cheaper if we did it earlier in the game. So yeah, I don't know what the best way to codify this expectation is, but roughly the way I see it is like it is somehow the responsibility of the ADR author to build consensus around the path to implementation. And people who are going to review should have their chance to be there and then to say, oh, I think maybe this would be something that I could imagine understanding with my understanding. Like I knew nothing about, I don't know much about blockchain in general, but I didn't know anything about the blockchain reactor when I started. So I had this very like novel experience, and I think reviewers should be novices. They should go in with like no context. Yeah. So what is the best way to codify? Does that make sense as an expectation? Number one.
Yeah.
Number two, what is the best way to codify this so we don't forget? There's an ADR template, maybe.
Yeah, I think we do it in ADR template. I mean, this kind of goes back to the discussion about the separation between the spec and the implementation trajectory, and we've kind of conflated the two in the ADR process. And I think we kind of want the ADRs to be a little bit more specifically about implementation, and maybe the specs can somehow be separated out. But in any case, for now, so long as that's not the case, maybe we have ADRs that are more purely about the spec, and then an ADR that's about how the implementation is going to proceed to actually realize that spec.
Yep. I think that also makes sense.
Yeah. Yeah.
Cool.
Okay, guys, that was great. Thanks, everyone. I'm going to stop recording.
Or we do